Today we're going to be looking at equations, inequalities, and nature of roots. So technically this is a grade 11 section. However, it's a section that's going to be examined in grade 12 as well. So if you're a grade 12 student, you can definitely be using this as good exam preparation for your June, your September, and your November exams. All right, there's a lot of remembers here. I'm going to just run through them quickly. Obviously, when we look at solutions for an equation, just remember that we are also thinking about the roots of an equation. And if we're talking about a quadratic equation or a linear equation, even a cubic, then we could also be talking about the x-intercepts of the graph when we are solving an equation. Then keep in mind that if it's a linear equation, it has one solution, quadratic, two solutions, and a cubic, three solutions. You could, of course, have equal solutions. So the 1, 2, and 3 don't necessarily have to be unique solutions, but that's what we expect. You need to be familiar with your quadratic formula. It is given to you on your formula sheet. And then, of course, you need to remember delta. So delta is actually just the part of your quadratic formula that sits under the square root sign. So if you understand where delta comes from, you basically don't have to learn the rules for nature of roots. You just have to understand what happens when you square root a negative number, when you square root a perfect square, or when you square root a number which is not a perfect square, or if you square root 0. Okay, then your different types of equations. Obviously, if you're doing the squaring both sides type, remember that you have to check your solutions at the end. Why? Because you've turned a linear equation into a quadratic equation when you square both sides. And so one of your solutions might well not be valid. If you use the K method, you can simplify a really complex looking equation. So it's very helpful if your equation looks like it's going to have a degree higher than 3. Simultaneous equations, just watch out for maybe some of the trickier ones of exponential equations and ratios. We'll have a look at one of those. Then your quadratic inequalities. Remember that you can use a parabola as part of your working. And in quadratic inequalities, you will give your answer in intervals. And then lastly, the nature of roots. Just be aware that nature of roots doesn't have to be a standalone question. The nature of roots could well be part of a parabola question. It even comes up in analytical geometry, more likely in grade 12 there, with a circle and a straight line. Right, so here's a couple of quite interesting exam style questions. The first one, solve for x if x is this expression. And then they give us this huge number for a. Now, I don't know about you, but I'm lazy. I don't want to have to go and substitute all of those 8s into a squared and then into a. And my calculator is not going to help me anyway. So clearly the trick here is to try and simplify the expression before we substitute a. So I'm going to try that. I'm going to say my numerator is a quadratic trinomial. And so if I make it a plus 2 and a minus 1, denominator a minus 1, and now we can see, hooray, those are going to cancel out, divide out. And so I'm left with x is equal to a plus 2. And now all we've got to do is be careful not to be tricked by the plussing of 2. So it's the 8 at the end that's having the 2 added. So a good way to look at it would be to say it's 88 plus 2. Okay, so don't get caught out there. So it's only going to change the last two digits. These guys all stay the same. And there is our final answer. But just for fun, I decided to add in my own one and say, what would your answer be if it was nines with an 8 at the end? So now remember, the difference would be that you have a whole lot of nines which have to round up. So now you're saying 98 plus 2. So if it's 98 plus 2, we're going to have to round it up to 100, carry the 1, carry the 1, carry the 1. And so we have that as our final answer. Okay, so that would be 1,000 billion. So just be careful of the 8s versus the 9s. Okay, don't let your brain play tricks on you there. Right, this is a little old favorite. Given that, determine x if y is equal to 4. Okay, well, if y is equal to 4, then we've got x minus 3 times 8 equals 0. So clearly 8 can't be 0, and therefore the only thing that can be 0 is the x minus 3. And so we would say x has to be 3. That's the only possible correct answer for that one. The second one, y is negative 4. So now the second bracket is 0. So x minus 3 times 0 is equal to 0. Would you agree that it makes no difference what x is? That answer is always going to be 0. And so x is any real number, because whatever x is doesn't affect the fact that you're multiplying by 0. All right, so that's just a little trick in that one. This is another one that's becoming popular again. Calculate the maximum value of S given that S is this expression. So I'm sure you'll agree that the 6 in the numerator can't change. So 6 is a constant. Therefore, it's only the denominator that can change. So the bigger the denominator, the smaller the overall answer will be. Vice versa, the smaller the denominator, the bigger the whole expression would be. So what we actually want to get the overall maximum is the minimum of x squared plus 2. Okay, now, x squared is a perfect square. It can never be negative. So the smallest value that x squared can have is 0. So therefore, x squared plus 2 has to be greater than or equal to 2, which means that the minimum value of the denominator is 2. If the minimum of the denominator is 2, then the maximum of S will be 6 divided by 2, which is 3. So it's a conceptual understanding that the whole fraction gets bigger as the denominator gets smaller. Right. This one has caught a few people out over time, so we're just having a look at it. Consider the given equation, calculate the values of the ratio x over y. So at a first glance, you're going to look at that and go, oh, I don't actually know how to do ratios anymore. The last time I did those was in grade 8. But remember, this is just a quadratic trinomial. So it's an equation, it's a quadratic equation. So start with what's familiar and hopefully you'll be able to sort it out and answer it in due course. So if I factorize this guy, it's got to be x and x, it's got to be plus and plus. So factors of 6 which add to make 5. And there we have our factorized expression. So x is equal to minus 3y, or x is equal to minus 2y. But they didn't say solve for x. They said, what is the value of x over y? So on the right, the y is multiplying. So if I bring it to the left, I'm dividing. And likewise here. Okay, and so we found the values of the ratio. So x over y is minus 3 over 1 or minus 2 over 1, so to speak. Then it goes on with a hence. Hence solve for x and y if x plus y is equal to 8. Okay, so now possibly your ratio is less helpful. I think it's better to go back to this step and then we can substitute. So instead of x, I'm going to put minus 3y. So minus 3y plus y is equal to 8, or minus 2y plus y is equal to 8. So that's going to give me minus 2y equals 8. So y is minus 4, or minus y equals 8, which means that y is negative 8. Okay, so it sounded like such a complicated question to get those 7 marks, but in fact, it was fairly straightforward. Do what you know, and hopefully you'll be able to see the connection.